All right, we'll start. I think the clock is ticking. Well, hello there, and welcome to our session about development and management practices for mobile services. My name is Kirill Gavriluk, and here with me is Paul Badam.
Hey.
We work on mobile services team. It's really great to see you guys here after 3 days and a party. Appreciate the attention. I hope we are not going to disappoint you. So today, we're going to talk about mobile services development and management practices. How many of you have not yet attended a single mobile services session? All right, I guess there are very few. So, brief recap, mobile services makes it very easy to add a backend to your modern app, whether it's Windows Store app, Windows Phone, iOS, Android, and a few other platforms. Mobile services provide native SDK for all of those platforms. That makes it very easy to take advantage of backend capabilities like authentication with any of the popular identity providers, storing structured data in the cloud, adding backend logic, extending your backend with custom logic, doing push notifications, and so on. All of these capabilities are available through native SDKs, as well as REST API that you can use on any other platform. Today, we are not going to be talking about features. Today's session is about day-to-day developer routine with mobile services. We're going to talk about development and test practices with mobile services, what to watch out for when it comes to perf, what do you need to do before you submit your app to the store that uses mobile services, how do you know that it's running, and finally, as always, we'll forget about versioning and we'll discover at the end. All right, let me quickly introduce you to our applications that we're going to use throughout this session. The application called Event Buddy, it uses mobile services. Some of you may have seen it before. And it's very handy for me to keep track of events and sessions where I speak. So here I have one event, built 2013. I can log in using mobile services and using any of the 4 identity providers. I'll choose Facebook and log in with my Facebook credentials. Then I can go on into one of my events and I can add a session. And this way I can track my sessions. I can add other speakers. Other speakers can add sessions. So handy session tracker app. What I'd like to do with this app is add a feature to be able to rate sessions so that attendees can also use this app on their devices and rate my sessions. And I'm going to do this all from Visual Studio because in Visual Studio 2013 we have built-in tooling for mobile services. Let's go to Server Explorer, and you can see, maybe not. You can see here our mobile service event body, KG, and I'm going to add a rating table so that I can submit ratings and store them in mobile services. While it's creating the table, next thing I'm going to do is I'm going to add a script to mobile service that would send a push notification in response for folks rating my session so that I, as a speaker, get a notification when my session is rated. Using the new features from mobile services, I can do it directly from Visual Studio. I'm going to use source control. With adding source control in mobile services, it really means that we added a Git repository right in mobile service that you can interact with from your local Git repository. Git is a distributed source control protocol. You can work with your scripts locally on your box in Visual Studio, commit your changes locally, then push them to a proper source control system like TFS that also supports Git. And then you can push those changes also to your mobile service so that they become live instantly. And that's what I'm going to do. Right here in Visual Studio, I have a service node in my client project. And this service node had folders for all types of scripts we support in mobile services. You can add custom APIs. You can add scripts associated with your tables. You can add scheduler scripts. For those of you who are familiar with features of mobile services, all of your scripts can be stored in this folder. And this folder is synchronized with the Git repository over in mobile service. So I can go ahead and add a script to it. Rating insert. And this script is fairly straightforward. What it does is anytime someone rates a session and an item is inserted in a rating table, in this script we're going to query for device tokens that belong to the speakers of that session and send them a white tile over here. So notifies them that their session was rated. What I'm going to do is I'm going to commit using Git support in Visual Studio. Interesting. I guess I already have it committed. All right. And then I'm going to go to the Git. I'm going to first make sure that my client is synchronized with my repository in mobile service. So I'm going to pull all the changes down. And I think my rating session is already, my rating script is already committed. So normally I would just push my changes to mobile service.
You could try editing the script. Just put a bit of white space in there. Save that.
Let's do that.
And you should see that come up.
Thanks, Paul. Let's commit this change. All right.
Always got to have a git commit message. You can't not do one. It won't let you.
Commit it, and then I'm going to push those commits. And now my service is live. Now I can check in Server Explorer, because Server Explorer is a true live representation of your mobile service. I can check in the Server Explorer that on my rating table, I have the insert script, and it's going to pull the script that I just committed. And so here my script is already live and working. So what are we going to do now is we need to rate a session, because my app is already there, my script is already there, we're ready to see if push notifications work. Now I need a volunteer to rate my session.
I think I can help you out with that, Kirill.
Excellent. Thank you, Paul.
So if we can switch over. So I have a iOS client here for Event Buddy set up already with the functionality for doing the ratings. And it's set up to be pointing at Kirill's mobile service. You can see that here, Event Buddy KG. It's the same one. So I'm going to go ahead and run this. And this is just, this is using our native iOS SDK for mobile services. And it's going to load up a little phone app. It's going to log me in with Twitter. I've logged in before, so it remembered my credentials. And you can see the build app is there, build session is there, and our go live session is here. But after that, demo was a little wonky. I think I'm just probably going to give you 2 stars at the moment, Kirill. Now, why don't we switch over and see if we get our tile updating. You want to scroll over? See whether or not that works. Great. Okay.
Oh, thank you, Paul.
So everything's working all right.
Thank you, Paul, for rating my session so generously. Now, in order for us to increase our rating, Would you mind helping us?
Yeah. I think I could do some, I've already got my client set up. I could do some back-end development as well.
I see. But the issue is that you have a Mac. I don't know how you're going to do this. You don't have Visual Studio.
That's okay. So, I mean, yeah, I won't do it through Visual Studio. I could do it through the portal, but actually, I'm really keen on automation. So I think what I'll do, if you can switch back to me, I'll give you guys a demo of the Azure command line tools. They're cross-platform tools that work equally well on Windows and Mac. And they're really great for automating like pretty much anything that you can do in the portal, you can automate through these tools. Now, to get started, I'm going to install the Azure CLI. So I'm going to use NPM to do that. Now, NPM is, if you're not familiar with it, it's like the Node.js version of NuGet. That's the way I like to think about it. So this is like doing an install package from Visual Studio, for example. Now, if I run this, it's going to go and pull down a bunch of bits for the command line interface so that I can go and start working with my mobile services. Now, the next step, of course, is I need to handle authentication. Like my client, my command line here isn't logged into the Azure portal. Now, it's pretty easy to do that. I'm going to do an Azure account download. And that should pop open a browser that's going to grab me a file, a publish settings file. And then if I switch back to the terminal and I say Azure account import and grab this file and drag it over, it's going to pull down the accounts. Now, what I want to look at is what did I get from the publish settings? My Azure account can have multiple subscriptions. We're working with Kirill's subscription today, so I'll say Azure account set. And then if I've done that all correctly, I should be able to get a list of the mobile services that are on your subscription, Kirill. Great, so that worked fine, and Event Buddy KG is there, and that's your instance. But what I want to do is set up my own, because really as a developer, I want to have my own environment that's separate from the other developers so that we don't interfere with each other. And even if I was the only developer on my application doing my back-end work, I still want multiple environments for dev, for test, for prod. So I want to do that automation. I have a script set up ready to go to do this. So if I have a look here, I have an Event Buddy script. I'm going to get this running, and while it's running, we'll take a look at what it does. So I'm going to call my copy of the app Event Buddy PB. We'll get this going. All right, that's going to take a couple of minutes, so let's take a look at the script. So the script here is, at the moment, because I'm on my non-Windows machine, it's a bash script. But the script would look really, really similar if it was like just a batch script. It's just a sequence of commands. I want to create my mobile service, create it with the name I specified. Here are the SQL credentials. Here's the SQL server and the database to use. And at the end there, here's the location of where I want the mobile service created at. And then once the mobile service is created, there's a whole bunch of settings that I want put onto the mobile service so it's ready to go. In the case of the first two, I have my Microsoft account client secret and package SID so that I can send push notifications to the Windows 8 client that Kirill is running. These are the same client secret and package SID that Kirill has configured in his instance. The next two I have is Twitter credentials, because my client is using Twitter to log in. Now, in the case of these, they're different from what Kirill has, because when you work with an auth provider, that auth provider is you're going to go create an app, and that auth provider is going to say, where should I redirect back to when the flow is done, when the authentication flow is done? It's going to redirect back to my instance, not Kirill's. So I went and created my own Twitter app and put those credentials here. Next, a few tables. The channel table, the event table, the rating table, the session table. Pretty straightforward stuff. Finally, I'm uploading a couple of scripts. I could have done this in one of two different ways. I could have, you can see here, I've just got some script files, and it's just going to push those scripts. I could have also skipped the script upload step, instead enabled source control, and cloned from the same Git repository that Kirill has and Git pushed that instead, and that would achieve the same goal. Let's see how the demo gods are treating me. hey, everything is green. Okay, sweet. So if I switch over to the portal, I should have, well, okay, I spoke too soon. It says my event body is still creating. That can't be right. Let me just refresh this and see if this comes through okay. Okay, it's there. Okay. So let's have a look. It should have a whole bunch of tables. Great. If I look at my push settings, they should be configured. Okay, so it looks like everything's been set up here. The real test, of course, is to see whether or not I can connect to it and run the app now that I have my own environment set up. Easiest way for me to do that is to copy some of the code that we have here in the quick start and then go and drop it into Xcode. Paste that over the top here and then run again. And this time, event body should be working, but I'm hitting a new Twitter app, so it's probably going to ask me to, oh, it didn't ask me to log in. I guess I'd already logged in for that app earlier as well. But you can see the session is not there. So I have my own environment now, separate from Kirill's. I can now do my script development, do whatever I want, and basically we're separate, and I've done it in an automated fashion, so it's really easy to repeat this process over and over. Let's check to see whether or not the app is actually running, so we'll add build 2013 for me as well. Now, of course, one thing that, yeah, so that seems to be working fine. One thing that you probably want to do as well, which I didn't do in this step for time, is you probably want to work with not like a blank database. The best pattern for this, I think, is you want to take like a sanitized copy of your production database or some earlier snapshot of it. Obviously, pull out anything that's any private information and so on. But get that to the point where you have the copy ready to go for development. And then you would just do one extra step, right, where with mobile services, we let you run multiple mobile services against the same database. They each use a SQL Server schema as a container to keep their data separate. If you were going to go and copy an existing database, you'd run a simple SQL script that would just change the schema of all the objects to be the same as your new mobile service. Okay, so I've got some automation working, and you know I'm set up there. I think what I want to do, though, is a little bit more back-end work. I want to work a bit with scripts. So the next thing I'm going to do is I'm going to take a look at how you can write better server-side scripts by unit testing those scripts. So I'm going to do that by running my scripts locally in Node.js, and I'm going to use a mocking framework that we've been working on to help make that easier. If I switch over to Sublime, go to my other window, I have the insert script that you saw Kirill running earlier. And I think by now you probably have a pretty good idea of what the script is doing. It's inserting the rating that the client sent, and then sending a response back to the client saying, okay, the record is saved. And then in the background, it's sending notifications by running some SQL on the database to find all the channels of the person who created the session. Because Kirill could be running lots of different Windows devices. He wants the push notification to appear on whatever one he's using currently. So it's a join between the sessions and the session owners and channels. So you can see it executes that query, and then it loops through the results, and it sends a push. So what I'm interested in doing is writing a unit test that confirms that I am actually sending the right push notifications based on this data. Now, that's a difficult thing to do if you're actually trying to do it with a live system. It's hard to unit test something like a push notification. But if instead you use a mocking framework that lets you not actually send the push, but instead see what would have been sent, that's a good way to unit test your scripts. So what I have here is I have a test set up for this script that I want to walk you through. So I'm using a thing called Zumock. It's kind of like mobile services. Its code name was Zumo, and I just can't let it go. And so I needed a mocking framework, so this was the obvious name. And so this is something that I've been working on a little bit to try to form an example of how it's not that actually hard to write a mocking framework for mobile services. And it's something that I hope to release in the near future. So we're using Node.js. We're going to load a few modules, the assert module and Zumock. And then we have a test here. This test is written using Mocha, which is basically like an NUnit for Node.js. I new up the Zumock, and then what it does is it looks at the file system, And it can see that over here, I have my rating insert and my rating JSON file. So it knows what tables I have locally. And so the code will actually automatically say, hey, you know what, your tables, they've got a rating. There's a rating table there. And I can go and create a rating just with some basic data. And I'm going to go and insert that rating into the rating table. Now, there's one extra step I need to do here for this unit test to work, and that's to handle the SQL query that's in the script. The SQL query, I want this test to run fast, like in local memory. I don't have a SQL database set up. I don't want to have a SQL database set up locally to run it. So what I have here is a fake out of what SQL was doing. I was doing a query to SQL, and it was returning me a couple of records that have some channel and some session information. So with all of those set up, I can now actually unit test the script by saying rating table, insert, and then Zumok will go, hey, there's an insert script, so I should run that. And then when that's done, I can then take a look at what happened. You can see here, Zumok's got a push.wns, like your table scripts have a push.wns. But I've added a new property, which is the log. What did we send? So let's take a look at that. We want the pushes to have the channels that we sent up earlier. And then we want all the information to be right. So I want the type of the push to be that wide tile. I need to send the right image. This should say 4 stars because the rating up here was 4, and so on. I mean, last one is just that, I'm saying I rated your session, and this is the session that I rated. Okay, so let's switch over and run the test. Okay, that's fine. So I'm going to say, demo failed. No. So I obviously wanted to show you that the unit test failed so that we could go and fix it and confirm that we actually do have a working unit test. So what is it saying? Well, the problem is that the message, Paul Badham just rated your session, session 1 didn't appear. It was expected, but instead I got undefined. So it looks like there's some problem with what I'm trying to concatenate on the end there. If I go back to the script, that's the test. Let's go back to the script itself. So here I'm saying rated your session. So what I'm supposed to do here is have the session's name. This item is the rating. So really I want the results from the SQL query. They have got the session right here. So let's save that, switch back, run the test again, and it's passing. So, I mean, I really only just scratched the surface here. Unit testing your mobile services scripts, depending on how complicated they're getting, is, there's definitely going to be a reasonable amount of work there. But there's, like Josh Twist blazed the trail of how to do this. He's got some great blog posts about unit testing your scripts. I looked at those and I was like, we can do better here. And so I'm hoping that we'll be able to make it so it's really easy for you to unit test your scripts and everybody is doing it. Okay, so in summary, you've seen, we have support for source control now in mobile services. You can deploy your scripts using Git, and even, we didn't get to show it to you today, but even if you're editing your scripts through the portal, if you have source control on, those changes are also being source controlled. You can automate your mobile services processes with the Azure CLI. And one thing I didn't mention is that we've certainly had some requests for PowerShell support, and that's something on the roadmap for us as well. Finally, unit test your scripts and use mocking frameworks to make that easier.
Well, thanks, Paul. That mocking framework was really cool, and I'm really excited that you're going to spend your vacation finishing it up. Next thing we want to talk about is perf. And we're not going to perf tune our specific event body application. Instead, we're going to walk you through several patterns and do's and don'ts when it comes to mobile services. The first pattern we're going to walk you through is where to store data. That's a pretty critical and vital question to answer when you start building your app using mobile services. Mobile services makes it very easy for you to store data in SQL, and that's where event body stores its data. And SQL is fantastic for storing relational data. If your app needs rich query support, sorting, filtering, multiple indexes, SQL is great. However, many apps have very simple data structures and very simple query requirements, We have one customer that is building games, and their game app has millions of sessions, and they need to store those game states. And the only query capability that they need is to retrieve that game state by ID. For those type of scenarios, Windows Azure provides table storage, a great service. I'm sure you guys have heard about it at least once. Mobile services with recent new capabilities like custom API make it very easy for you to store data in Windows Azure table storage. Here's an example of a script that does it for you. We have an Azure module. Azure module gives you access to any Windows Azure service out there from within mobile services scripts. And in this case, we have a custom API retrieving event body sessions from an Azure table as opposed to SQL. You have Azure module. You can get to table service APIs. We provide you a very simple query builder, somewhat inspired by Link. And you can easily execute it and get entities and return it to the client. The next pattern I'm going to talk to you is how to store image and blob data with mobile services. What we've noticed since we went into a preview that some apps store blobs and images directly in mobile services in SQL. And while it may work if you have very small number of binary data blobs and they're small in size, SQL is certainly not optimized for storing large volume of binary data. We have SkyDrive, we have Windows Azure Blob Storage. Those are great services to store your binary data. SkyDrive is great for storing images that belong to your users. And Windows Azure Blob Storage is great for storing application binary blobs and data. There are two ways how you can work with blob storage. You can authenticate with it using your storage account key, or you can authenticate with it using shared access signatures key. Now, if you have your storage account key, it gives you access to everything within your storage account, all your blobs, containers. And if you put it inside your client app, deploy it to the store, it gets deployed to all the clients, anyone can crack that app, get your storage account key, and from there on, your storage account is really not your storage account anymore. A better way to do it is to use shared access signatures. Those are short-lived, expiring tokens that you can retrieve from blob storage on the server and give it to the client. And mobile services is great for brokering this key exchange. With mobile services here, what we can do is client can request mobile service for URL to store blob, to upload the blob. Mobile service can go and ask blob storage, hey, here's the storage account key, give me a SAS token that I can give to the client. It gets a SAS token, sends it back to the client. Now the client can upload blob directly to the blob storage. The usage of the wire is efficient. We're storing blobs in blob storage, and we're doing it in a secure way. We're not compromising your storage account key. So SAS keys, very important when you work with blob storage from the client. Here's a simple example of the mobile services script that retrieves the SAS key. Again, you use Azure modules. You have blob service APIs within Azure module, and you can generate shared access signature and request the SAS token from the blob storage. Over the next few slides, I'm going to walk you through some silly scripts that I wrote, and Paul can attest that I write a lot of silly scripts. And those silly scripts hopefully illustrate what not to do with mobile services. Here is the first example. We notice sometimes folks put a fairly intensive compute inside those scripts. Here, for example, we are converting an image. That's something you don't want to do inside your mobile services scripts. Mobile services scripts use Node.js, and they run in a Node.js scripting environment, which is a single-threaded event-based. So whenever you do some synchronous work directly in your script, and it's intensive, you're blocking that event loop, and nothing else can get executed. A better way is to offload this type of work to your backend, either using scheduler script or get a worker role if you're really doing some intensive compute. Mobile services scripts are great for accepting processing requests, and if you have some compute to do with them, put them in a queue, process them in a scheduled script, that a cron job service that mobile services provide, or process it in a worker role. Here's another example that we see some folks do, is doing iteration over multiple tables at once. So here we're iterating over a post table, which contains all blog posts, and then we're getting all the users from it, and then we iterate over the channels table, and then send notifications to those users. We're effectively doing a join. We're doing it very inefficiently. Mobile services allow you to work directly with SQL, and so instead, you can use SQL. We have an MS SQL module. You can directly push your SQL statement directly to SQL and execute joins there. Here's another thing that we noticed some folks do, is doing a large number of I/O requests from within mobile services scripts. I mean, it's okay if it's a manageable number, but here we are trying to push notifications to everyone in San Francisco that uses an app. And if our app is successful, that's a lot. That's a lot of push notifications. There are dedicated services that do this type of high-scale I/O workload much better. In case of push notifications, we have notification hubs, Windows Azure Notification Hubs service that we announced a couple months ago, that is really great at delivering notifications at scale and broadcasting to millions of devices. Elio, in fact, is going to have a session right after this one that will go into details about notification hubs and how to use them. Really great when you need to send push notifications at scale. If you're doing some custom I/O within your scripts, and it's a lot of I/O, it is a better idea to split them in batches and do those batches in a background process, like a cron job, like a scheduler script that you can use Windows Azure Mobile Services to create, or a worker role if you really are doing some really intensive compute constantly. Finally, we can move to the client, and on the client, we see sometimes kind of simple mistakes like this one, where folks use mobile services APIs, and mobile services APIs makes it very easy to interact with tables. So it's very easy to fall into the pitfall of, okay, I'm going to get a table, I'm going to iterate of all the rows, then I'm going to look into another table and iterate of all the rows related to my row. So basically, effectively doing a client-side join inside your client. That generates lots of API calls. That drains the battery. It also costs you, because as you have seen in the announcement of mobile services pricing is based on API calls. And doing lots of API calls, if you don't need to do them, it's not a good idea. Much better is to put them, batch the work, upload it and let mobile services script to take care of it. In this case, we can do joins inside mobile services script, and we can override the sessions script in this case, and do a join there with events, and get all the sessions that will happen in the future, instead of doing this join on the client. And then on the client, it's a very simple query against the mobile service. So let's not do client-side joins if we can avoid it. So we walked through a few patterns around perf. Obviously, you need to use the right data store for the right scenarios. Use SQL when you need rich queries. Use Windows Azure Table if your data structures are very simple and your query needs are very, very basic. Windows Azure Table gives you partitioning, gives you lots of goodness, and you can store lots of data of a simple structure. Do not use SQL to store your blobs. Use blob storage to do that. And we walk you through the shared access signature pattern. Use shared access signatures to interact with your storage accounts from your client. Avoid doing compute-intense operations inside your scripts. Use other services that are better at it, notification hubs, SQL when it comes to lots of select statements, or at least batch those I/O calls and move them to the background. And finally, be aware about the client-server communication and do it efficiently. Instead of doing lots of small API calls from the client and draining your battery, try to batch them, push them, and do the work on the server inside server scripts. So great, we've spent some time on perf, we optimized our app, we're ready to upload to the Windows Store. let's take a look at what steps we need to make before we submit the app to the store. We announced yesterday new mobile services pricing as part of mobile services general availability. Mobile services now is generally available in 3 tiers, free, standard, and premium. And standard and premium tiers come with an SLA of 99.9%. Within each standard and premium tier, you can get multiple instances for your mobile services. And so when you submit an app to the store and go to production, it is a good idea to move your mobile service out of the free tier to get an SLA, as well as you need to plan what tier to move to, what tier to start with. It is very easy to scale mobile service from one tier to another using the portal, but it's a good idea to estimate what is the initial load on your mobile service and pick the appropriate tier for your app. There are 2 considerations that you want to make. First is how many API calls, how much usage am I anticipating from my app? So standard tier, each instance gives you 1.5 million API calls. Probably good to start with. Maybe you need 1, maybe 2 instances. Now, while on average we give you 1.5 million API calls per instance, we certainly can handle a lot more during peak. So if you have a burst usage of your app, certainly those instances will handle a lot more than if you calculate the assumes 1.5 million API calls. I listed some numbers here. This is more as a guide. If you choose, so you need to anticipate what's the burst peak you anticipate in the first days of your app going into the store. And in standard tier, you can look at the number of 10 requests per second. In the premium tier, you can look at the number of 100 requests per second per instance. Your mileage may vary depending on what you do in your scripts. You need to test, see what the throughput is, and choose the right number of instances to handle the burst peak. You may also ask, well, why don't you guys just auto-scale it for me? It's a valid question, and believe me, it is coming pretty soon. So you need to think about the usage. You need to think about your burst activity for your service. Pick the right tier, pick the right number of instances. Few other things you need to think about before you go to production. Mobile services give you this great capability of dynamic schematization. So during development, it's very handy to just throw JSON objects at mobile service and not worry about designing your SQL schema. However, once you go into production, it's a good idea to disable dynamic schema functionality so that your app doesn't accidentally start creating lots of columns. You want to make sure that your tables and APIs in mobile service are secure. Authentication is enabled with the right set of providers that your app needs. We always use SSL by default, and all the tables need to be locked, and permissions need to be explicitly picked. Finally, you do want to set up your dev and test environments, just like Paul did a few minutes ago, and make sure that you can easily integrate changes between dev and test, and your dev test to production cycle is set up before you go to production. And lastly, and we haven't done it here, but you do need to think about versioning, and we're going to show you what happens if you don't think about versioning later. Well, great. We have our app now in production, running. Paul, how do we know that it's running?
Great question, Carol. So when we switch over, I have the portal up here. So I want to walk you through some great features that are built into Azure for monitoring and alerting. Basically, you want to know how are things going over time, and you want to know when something is starting to go wrong. So what I have here is I'm just going to go into my instance that I spun up earlier, and you can see that there's this mobile service endpoint status here. I need to configure this, turn this on, because what this is going to do is it's going to set up an agent that's going to regularly hit my service with an HTTP call to see if everything's okay. Now, to turn that on, I think I'm probably in free mode at the moment. I just need to scale up. So this will only take a few seconds. Once I'm scaled up, I can go to the Configure tab and set up my endpoint monitoring. It's going to ask me, where do I want the endpoint monitoring from? So if I click here, there's a few different locations. it's great to do endpoint monitoring from multiple locations because you can get a better picture of like your app's users, what is the experience they're getting. And you're also particularly interested in knowing about the latency, the perceived latency for your users in different areas. So I'll go local, and I'll pick San Jose, but I'll also go over to Europe. I'll grab Amsterdam as well, and then I'll save this. So this is provisioning basically a job that's going to be running in Azure infrastructure from different places around the world, hitting your service. And it's going to take a few minutes before this gets going. So I'm going to go and switch to Kirill's mobile service because I configured it earlier with endpoint monitoring. Okay, so there's been lots of activity on Kirill's mobile service over the last few days. We've been pretty busy. But if we look here, you can see the log of what the endpoint monitoring has observed. It has a bunch of requests that were made from Amsterdam. You can see we were around about half a second. And then some requests from San Jose, some that were a bit lower. And this is great in that I can see these on the graph here in the response time for these different locations. But it's one thing to just have this turned on and to be able to go and look at it. Really what we want is to be able to say, hey, if the latency gets really bad, send me an email. So let me show you how to do that. This is a pretty cool new feature that's available under Settings. You can see here there's this Alerts, which is in preview at the moment. So the idea with alerts is that you can create rules that are based on the metrics that are being captured by the in the case of mobile services, by the endpoint monitoring. I have a rule already there, but we'll look at that in a second. Let's go through the process of creating one. So demo alert, I want to say it's for a mobile service. Notice there's a bunch of other options as well here. So this is really cool. It applies to a bunch of Azure services. So let me go to my instance and set up a rule. So you can see here it's looked at the endpoint monitoring that I had set up for my mobile service, and it's saying, well, these are the different metrics that are available based on that. So in this case, I've got some response time metrics from Amsterdam and San Jose, and some uptime metrics as well. Uptime is it's hitting the service with an HTTP request, and it's seeing whether or not it got back at 200 in a timely manner. And if it got back some sort of 500, 502, something like that, that means there's something wrong, and that counts as a failed request, and that'll count against uptime. So for this, I'll set a rule saying that if users are getting over a 1 second latency from Europe, I'm at the point where something is getting pretty bad. The app experience has really started to degrade. So fire the alert if the latency goes above 1 second. Do that by calculating the average over the last 15 minutes. And most importantly, send me an email when something goes wrong. Now, I'll go ahead and create that. But again, for the purposes of this demo, it's a little bit difficult. I don't really want to sit around and wait for this process to get going. So I want to show you what an existing alert setup already looks like. So this is the one that I set up for Kirill's instance. And you can see here what it's showing is this is the data that this alert collected in response time. And then this blue line is the threshold that we set for the alert. In this case, I was ridiculously optimistic, and I said that I want 100 millisecond latency from Amsterdam to my mobile service here in the US. That's not going to happen. So you can see the alert has been firing. It says up here, actually it's been going for about a day now. Of course, the other thing that you want to see is the email. So it sent me an email earlier, so I thought I would quickly show you that as well. It was like, hey, your response time from Amsterdam to your mobile service is greater than 100 milliseconds. You probably want to take a look at that. So that's a brief overview of how you can get like really good information about your mobile service. You can set up the right types of alerts, and then you can be confident that you're going to find out quite easily if something is starting to go wrong. Maybe, for example, for something like latency, it's you have a query that's working on a database table, and that table is getting really, really big, and that query is taking longer and longer to hit. That's the type of example of how your latency could get worse. So what I want to do now is switch over. We've got some great stuff built in But we also have really cool partners for Azure. I'm sure you've all seen the add-on section here, where you can go and grab services from third-party providers and hook them in to your services in Azure. Today, what I want to do is I want to talk about New Relic. So New Relic provide an amazing end-to-end application performance monitoring and analysis tool. It's really quite incredible because it's able to hook into like every layer of your application. They have a agent that you can install in your client, so it's on your mobile app. They have an agent that you can install in your backend, so in this case, in your mobile service. And they also have an agent that you can set up that it's going to take a look at your database. So you're getting like this really good end-to-end picture. Now, probably the best way to get an idea of what it's about is actually see it in action. So I'll click this link, and it should sign me into the New Relic dashboard. I've already gone and set up the monitoring for my backend and for my Event Buddy iOS app. So we can have a quick look at some of the data it's got here. Now, I'm going to be able to barely scratch the surface here in terms of the amount of rich functionality that New Relic provide. As a quick example, you can see here I've got a breakdown now on my requests. And you can see here at the moment the thing that's taking the most time is getting the list of sessions. Now, if I go over, this is because I have my application monitoring set up here. So this is my mobile service backend. If I switch to mobile and look here, it's going to give me data that's been collected from my client application, the Event Buddy app I was running, the phone app. Amazing sort of view of the information in terms of where people are using your app from and so on. I just want to drill down a little bit and look at errors. So if I look at errors that are happening in my client, you can see at the moment I'm actually getting a lot of errors to do with talking to Twitter. And this is the type of insight that you're really only going to get by having some sort of client agent installed in your app, because my mobile service is never going to know about failures that my app is getting talking to Twitter unless I manually program that in. So if I drill down on this a little bit and take a look, it's actually going to get to the point of showing me the response body that I got from Twitter. And the problem here is that I've got old versions of my app running about that are still using Twitter's unauthenticated APIs. They got deprecated a few weeks ago, right? So now those APIs are deprecated. It's doing this user's API that I can't do unless I'm authenticated. Twitter's giving me a 404, but thanks to New Relic, I was able to see that. So in terms of how do you hook it in, let me show you what I did in my application here. I have a reference to the New Relic agent framework in my iOS app. And the amazing thing is that I had to write one line of code. You can see this line of code here, New Relic agent, start with application token. And that's all I did. It hooked itself in to the app and is now just collecting data and sending it to me from my dashboard. Similarly, the process for setting it up for mobile services, you drop in a few files, hook it in, it runs on startup, and then you don't have to do anything else. Now, I do need to caveat all this stuff. I wanted to really give you a glimpse of, with the portal and the monitoring and alerts, I showed you what's available today. New Relic, as a service, they're already providing monitoring for thousands and thousands of applications. But their support for Node.js apps, which is what we use for mobile services, is still in beta. And the process of how I hooked them up so that I was getting this data for my mobile service backend is also basically a preview. So I'm trying to show you what's coming. This is going to be turnkey. You're going to turn it on, and then you're going to get this rich set of information about what's happening on your backend and on your client app. If we go back to the slides, so what you've seen is how to do availability monitoring and alerts in the portal today. You can go and set those up now, and if you're running a mobile service in production, I think you should go and do that. And also how things are going to get even better with partners thanks to integration through the Azure Store.
Well, thanks, Paul. Now, about the Twitter error, it looks like we haven't thought about versioning because I don't think there is any way for us to upgrade that app anymore. So we're going to keep continuing getting those errors. So let's talk about versioning and what we should have done at the beginning. I'm going to walk you through I'm not going to spend a lot of time on versioning. The topic probably deserves an hour on its own. I'll just walk you through a couple patterns that are handy and hopefully will let you avoid pitfalls that our event body app just ran into. The first pattern is you want to make sure that the client always communicates a version to the service, so that if you want to add additional feature to your mobile service and ship a new version of your app and put it in the store, your old clients still work with your service. Standard stuff, we've done it for ages. Mobile Services API, Mobile Service Client, is built using HTTP client. And HTTP client has this very simple abstraction delegating handler, where you can hook in and write some codes that will get executed on every request. In this case, we're going to build a versioning handler, and we're going to append a version number to every call that we make to the mobile service. And we're going to plug it in right here in Mobile Services Client as part of the constructor. On the services side, now we are getting information from the clients what versions they are running. And so we can make decisions and only offer features. In this case, we wanted to add room information to our sessions, but we didn't want that room information to confuse our older clients that didn't know about this addition. So we can quickly check the version and make corresponding adjustment in our responses and how to treat the requests. The second pattern I want to talk to you about is, it's good when you can add additional functionality in a non-breaking way, but sometimes you have to break your clients. And this typically happens, you find a security bug and just really a design flaw in the service. And it happens. We can always try to avoid it, but it always sometimes happens. And in that case, it's really good if your app is smart enough so that it can prompt the user to upgrade if you want to instruct the app to upgrade. So in this case, I'm going to show you a quick demo of how, by adding few lines of code here and there, we can ensure that we can trigger an upgrade of our apps on the client. First, I'm going to add a simple API to my mobile service in Event Body that will allow clients to check their version. I'm going to use source control like before. So what I'm going to do is I'm going to go to my service folder, and zooming works, yay. Service folder has all types of scripts for my mobile service, and I'm going to use API folder and add a check updates API. I'm also going to add a metadata for those check updates so that that contains some permissions and security information. I'm going to select them and commit them to my local Git repository, just like I've done before. I'm not going to forget to add a comment. And off we go. We are committing our changes locally, and then we're going to push our changes to mobile service. And now we will have an API in mobile service that allows our client to check whether upgrade is needed. I'm going to go back to our client, and inside our session, I believe it's it's events page. I'm going to go to the events page, and inside the events page on Navigator 2, I'm going to add a little bit of code to check, to talk to our service and check if the client needs upgrading. I'm going to provide the versioning information, and then I'm going to invoke our API, check updates, using our new custom API just was announced last week. And the custom API, we added also corresponding client API to our mobile services client, so you can interact with APIs in an easy way. I'm going to invoke the check updates APIs that I just added to mobile service. And if I get back an upgrade message, I will pop up a dialog and ask the client to upgrade. If you're interested, the check update API on the server is also very simple. All it does is checks the version, and if the version is older than the time when you introduced a breaking change, it asks the client to upgrade.
And we need to give Josh Twist credit for this. He's got a blog post that shows you the code for this sort of stuff.
Thank you, Josh. I think actually lots of our session was inspired by Josh's blog.
Yeah.
So let's run this app. And we see the message that asks us to upgrade. And we click and we get the Windows Store upgrade dialog that will let us to select an update to our app and install. So very simple, no rocket science, very simple pattern to enable your client to update when you really need them to. Let me switch back to the slides. Well, great. We looked at the versioning. Really just dipped our toes in the versioning C. You do want to always add your client version information to your request to your mobile service. It's very easy to do that using the request handler abstraction. You always want to handle the version differences in your scripts. And you do want to think about the upgrade problem and put an simple upgrade strategy like the one we showed you in your client. We just spent an hour on day-to-day routines and practices for building your mobile service, taking it to production, monitoring it, and knowing whether it runs or not. You always want to unit test your mobile services scripts. It's code. Even though it's very easy to add them, you can add them in the portal, but they're always stored in source control, and you can also store them in a proper source control system like TFS. And using Git, very simple Git workflow, you can push those changes to your scripts up to mobile service to make them go live. You want to think about performance, optimizing your client to server communication. You want to think about the right tier for your mobile service when you go to production to make sure that the service is running and can handle the load. Windows Azure provides rich alerts and monitoring infrastructure for all services, including mobile services. So you can always be aware whether your service is running or not, and will send you mail if it doesn't. You can measure your latencies from all over the world and see how your app is performing and what experience your clients get. And finally, always think about versioning upfront. Thank you, guys, and it's time for a couple questions. I do want to mention that we have a number of sessions about mobile services. There are a few still remaining during this day. We're going to have Elio talking about push notifications at scale. Dinesh is going to talk about identity using for mobile apps. And Nick is going to talk about go deeper into Windows Blue and how you can use mobile services to build Windows Blue apps. We're ready for a short Q&A session. Thank you.
Thanks.
I have a question.
Yep.
About your unit test, it seems like you guys are building a new unit test framework. Why not use Visual Studio? Are you guys planning to update that at all? The unit testing framework tools in Visual Studio.
Right. So yeah. So the question was, you saw me running unit tests basically from a command line and writing them. And running them in Node.js, and were you asking about VS tooling for that? So the thing is at the moment, because your mobile services, like your scripts are written in JavaScript, but they can use a lot of Node.js functionality, you're really just going to have a lot of trouble getting good unit tests that actually have the right behavior, that emulate what you're doing, unless you run them in Node.js. And at the moment, I'm just not aware of a good way. You could edit, like I could have totally edited the script, right, in Visual Studio. I would add it to the same solution like Kirill had, source control it the same way. But in terms of actually running the test, I need to use a Node.js test framework to do that because I need the test to run in Node.js, so it's got access to all Node.js's libraries and functionality and that sort of thing. Does that make sense? Important
comment, though, that .NET support for mobile services is also coming. So we'll have both .NET and JavaScript. We are really not married to a single language.
Yeah,
and you can leverage a lot of unit test frameworks for .NET code once it's available.
The framework that you guys are building, is that, will you be able to automate those unit tests on check-in?
So it's just a command line script. What you would probably do is, for example, it depends on like what build system you have, but it would be easy to have a machine set up with Node.js going, and then you would just send it just a single command, and you could do that from your build script or your continuous integration script or whatever?
The answer is yes. You can do it. TFS already has hooks. You can do it in TFS and run those tests. There's a question.
You were showing the new relic. Is that a plugin or on the portal? When you add that and you get the sample code, the to-do sample code from mobile services, does it already have the framework that you were showing in Xcode? Did you have to add that manually, or was that already brought down in the skeleton?
Okay, so what I did for setting up New Relic is they have a couple of separate downloads. So I went and set it up in the portal, added it as an add-on. That meant I could go, once it was added as an add-on, I could go to the New Relic page and it had my account details, like my license key and so on. Then I went to their download section, and they have a download section for their client plugins at the moment. You saw the iOS one available today. I think they have like an Android one as well, and there's more coming soon.
They're working on more.
There's more coming soon.
Yeah. Their client framework is still in development. It's not production yet, it's beta. But they're adding, I mean, it's very promising, and they're adding more support for all platforms.
Now, what I did on the server was a couple of manual steps. I've been chatting with the New Relic guys basically about the best way to get mobile services hooked in. At the moment, like what you really need is you need like a one-liner, like at the very beginning when the mobile service starts up to like require New Relic. And basically I have a few scripts that will copy that into the right place when you deploy your mobile service. But as I said before, it's really this is something that's just coming. Like at the moment, we wanted to show that you can turn New Relic on for your mobile service app and get data both client and server. That process, we do have a few things to work out there, I'll admit. Sorry about that.
Any other questions, guys? Yes, go ahead.
So there's an MSSQL driver in there. Is that available outside?
Yes, so the MS SQL driver, which we use in mobile services to do all your interaction with SQL Server, it's available as a separate GitHub library, a library that's on GitHub. So if you search for a SQL Server node, I think.
Yeah, MS SQL node.
Well, they changed the name of it at least once, so I wasn't.
It's a MS SQL node on SQL.
Let me see if I can find it real.
If you Bing for my MS SQL, you'll find for Node.js, you'll find the module.
It's under Windows Azure. It's called Node-SQL Server. All right, well, I think we're over time. I think we're done. Thanks very much, everybody.
Thank you, guys.